Okay, exercise 2.6, Year 10 Mathscape, complementary results. Now, this might look a bit strange to you, but sine and cos, actually I'll tell you why they're called complementary. You know how we write sine? You know how we call it sine? That says sin. It's actually shorthand for sine, S-I-N-E. See how you see cos? Cos? That's actually shorthand. That is shorthand for cosine. So sine is really sine. Cos is really short for saying cosine. Now, if you look at sine and cosine, what is the difference between those? Co. Guess what that means? They're complementary. Okay, so they're complementary. And from your work with angles, we've got sine and cosine, and the difference between them is co. That's co for complementary. So they're complementary angles. So if I draw the right angle triangle, and I know that the angle sum of a right angle triangle is 180 degrees. But if this angle down here is theta, now if you've got a right angle triangle and you want to work out this remaining angle up there, don't you say, well, this is already 90, so these two add up to 90? Or would you go 180 minus 90 minus whatever that one is? So you would say that's 90, so therefore these two are 90. So if that's theta, this one is 90 minus whatever the other one is. So if that's 10, you say to yourself, 90 minus 10, this one's 80. If that's 20, this one's 90 minus 20, which is 70. Get the idea? If that's 30, this is 90 minus 30. So if theta is 30, that would be 90 minus 30 is 60. So let's just look here. I'm going to call this side A, side B, side C. So let's look at the sine of theta. What does it equal according to these letters? Sine of theta is, what is it? Opposite over hypotenuse, B over C. Let's look at what the cos. Now, how do I know which angle I'm working from? It's the sine of this angle, sine of theta, is B over C. So if I'm asking you for the cos of 90 minus theta, it's the cos of this angle. What's cos of cos? Isn't that adjacent over hypotenuse? So what's adjacent? B over C. So if you're in the same right angle triangle, then the sine of this angle equals the cos of that one. Makes sense, right? I could have done 3, 4, 5, but it doesn't matter. So therefore, can't we say that the sine of theta equals the cos of 90 minus theta? Okay, that's where the rule comes from. Now, I can do the same for cos theta and sine of 90 minus theta. Okay, see, if it's opposite from one side, it's the adjacent when you're looking from the other angle. See, from here, the B is opposite. From here, from 90 minus theta, the B is adjacent. And that's how sine and cos are related. Okay? So, remember here, we're just proving the result. Okay? Again, if I look at what cos of theta and sine 90 minus theta are, I should get the same answer. So cos of theta, that's adjacent over hypotenuse. What do you get? A over C. That's an A. And sine of 90 minus theta, so from this angle, that's my reference point now, sine is opposite over hypotenuse. What is it? Again, A over C. So therefore, cos of theta equals the sine of 90 minus theta. I know this is a bit blurry. Okay. What you'll notice about the sine theta and the cos 90 minus theta, we know, look, theta and 90 minus theta add up to 90, don't they? Don't these two angles add up to 90? So I'm just saying, notice this, that those two angles, I can put this one in brackets, but it doesn't matter. These two angles add up to 90, all right? Now for some examples on complementary results. Remember that sine and cos, where did this really come from? It's come from a right angle triangle. What do the 35 and the x, what are they supposed to add up to, girls? 90. So this is what I just do. I can just say to myself, well, x plus 35 is 90. Does that make sense? X is 90 minus 35, which is, what is it? I think it's 55. Yeah. So therefore, x is 55. So cos 35 is the same as sine 55. If you want, you can check it on your calculator. Just think where this came from. It's a right angle triangle. If one angle in one corner is 35, the other one's 55. The missing angle. Just remember what I was just doing with that right angle triangle. So the sine and the cos in the one triangle always add up to 90 degrees. Cos 35 equals sine 55. Okay? What about this one? What does the x, doesn't matter which way you do it as well, the x and the 71 add up to 90. So x is 90 minus 71, which is 19. And if you go to your calculator, and so I'm just going to say, well, sine of 71 is the same as cos of 19. Here, cos of 35, I know I've worked out x here, but it's equal to sine 55, just to reinforce it. All right, so if you actually go to your calculator, you're not going to get exact answers for these. You will get a decimal answer. If you do cos 35, jot it down, you'll see that sine 55 is exactly the same answer. Okay. So basically, just that and that adds up to 90. That's it. Question 6b, simplify without a calculator. Cos of 74 over sine of 16. Do you reckon that 74 and 16 make 90? So we can do this two ways. I can say this is the same as cos 74 over, if I change sine 16, what's sine 16? Cos of? Do you want me to use the actual rule? Sine theta is cos 90 minus theta. Well, isn't that cos of 90 minus 16? See? Sine of whatever I've got here is cos of 90 minus that, instead of doing all that work there on the side. Isn't that cos 74 over cos 74? Girls? It is. Sine 16 can be written as cos whatever 90 minus 16 is, which is cos 74. See, I'm trying to get you, I'm going to actually write out a whole heap of them. So that's really the same as, of course I can't divide cos 74 by sine 16. When you see sine and cos, look, there are a few things you can do. You're either going to change them into tan if we're asking you to solve an equation, or sine 16, if you look at the rule, because the rule is sine theta is cos 90 minus theta, or I just look at that and make sure that this number and that one add up to 90. So if you want to use the formula, if you want to use the formula, you can say sine 16 is cos of 90 minus 16, because that sine theta is cos 90 minus theta. Now, sine 16 is the same as cos 74. What's cos 74 over cos 74? 1. Now, the other way I could have done this is changed cos 74 into, no, not tan, no, sine 16. See, cos 74 is also sine 16. So I could have gone sine 16 over sine 16. Okay, I'm not solving an equation, I'm just simplifying here. All right? Do you get that? All right, what about this one? This isn't very nice. See, the reason, sine of 10, what does that equal? Cos of what? Why are you telling me that? Because, yeah, or 10 and 80 add up to 90. Sine of 20 equals cos of, and this one, which we were doing yesterday and earlier today, the exact ratio, sine of 30 equals, hello, right, hey, what about sine 45? What does that equal? Cos 45. Why? Because 45 and 45 add up to 90. And what does sine of 60 equal? Cos of 30. Do you remember how I said the next thing we're going to do, you actually know it, but you don't know that you know it? All right? You know this, but you don't know that you know it. You don't know that it's actually that rule. Right? So, get it? What's sine of 80? Cos of 10. Now, you can go 90 minus, but the other way to do it is say that 80 and 10 add up to 90. 60 and 30 add up to 90. So this is what I want you to do with something like this. Please don't go 90 minus. It'll be a nightmare. So you just go x plus 30 and the 20 add up to 90. Why am I saying such a thing? Oh, they're called complementary angles, and complementary angles results add up to 90. You know, like in angles year 7, complementary angles add up to 90. Complementary results add up to 90 too. The angles of the complementary results add up to 90. Got it? So that x plus 30, as long as it's a sine and cos, girls, don't add up two sines. The sine angle plus the cos angle add up to 90. You can see it. So isn't this easier to solve? X plus 50 is 90. Just take a guess. What's x? 40. Complementary. If you remember complementary, you say, yep, that and that add up to 90, right? Or that is 90 minus, but try and do 90 minus with this. You'd have to write 90 minus bracket x plus 30 equals 20, and we don't want to be doing that. All right, one more. Complementary with these as well. X over 4 plus 30 equals 90. Do we get it? Yeah. So therefore, x over 4 equals 60. You got it? X is 60 times 4, which is 240. With this one, 2x plus 56 plus the 14 is 90. That and that make 90. And just solve the equation. 2x plus, what's this, 70 is 90. That means that the 2x has to be 20. In other words, the x is 10. Okay, this last question, 8a. If cos of 75 degrees is 0.26, find an approximate value for cos 75 plus sine 75. We know that cos 75 equals sine of, if you want, you can write, you know that 75 and 15 makes 90. So that equals sine 15, or you could write sine of 90 minus 75, which is sine 15. So therefore, cos of 75 degrees equals sine of 15 degrees. So if you want to come up with an approximate value for cos of 75 degrees plus sine of 15 degrees, you would write cos of 75 is 0.26. We know that that also equals sine 75, which is 0.26. And so therefore 0.26 plus 0.26 is 0.52. Girls.